Now this is post-fire blue bunch wheatgrass on the Sinlahegan Wildlife Area where we did a prescribed burn. And you can see the charcoal or the blackened crowns of the blue bunch wheatgrass. And the blue bunch wheatgrass did not produce a lot of seed heads the first season. This is a spring burn, and it didn't produce a lot of seed heads, but it did produce a lot of vegetative growth. The next year was incredible, the amount of seed that was produced. And the plants were very, very healthy and robust.
And this was reprod by itself naturally?
Yep. Now, this plant didn't, you can see where it burned out in the center. The thatch was pretty thick in there, and the fire burned the thatch, and I doubt that there was anything living in there anyway, but that heat resided in there for a while, and I'm sure that it contributed to killing any live material inside that clump. And you can see around the perimeter there's some growth. You can see the thatch that's built up in the center of the clump, blue bunch. So that's a good reason to burn it periodically, is to eliminate this. And even when you burn it, it doesn't necessarily eliminate it. But of course, we're burning when the conditions are, it's in control. Yes.
Maybe this is better for after the end, but it seems that any decisions we make about Shrub-Steppe are value judgments that we're making without a lot of data. It seems like most of what we like about Shrub-Steppe will come back. We'll come back mostly as grasslands because the sagebrush can't recover that fast. But
Right.
it's not clear why we should choose one or the other, and the amount of effort to influence a post-burn seems enormous.
Right. Yeah. I would agree with that.
So mostly we get to stand back, unlike forests where we kind of miss the trees. In this case, we get to stand back a lot and just watch nature do its things.
Right. But I would caution even jumping into planting trees and so forth. There's going to be a tremendous amount of reproduction as a result of the fire. Ponderosa pine really does well after that. The seeds start coming up. There'll be a carpet of young pines out there. So we'll be right into the cycle again. Mother Nature's been at this for a long time. And this is a basin wild rye, a deep-rooted grass. Again, this is down in the Ellensburg area. You can see the cheatgrass, real heavy standing cheatgrass. The bitterbrush skeletons scattered around. I didn't get out there and walk around to see if there was any resprouting, but that the issue is the cheatgrass being highly flammable could carry a fire through here again and kill off the shrubs and do a pretty permanent job on it. Yes?
Is there any reason to leave bitterbrush there other than to provide some habitat
For bluebirds while they're perched out there?
Yeah.
Yeah.
Was that
Yeah.
what else?
Is there any reason to leave the bitterbrush skeletons on the landscape? Yes. Bird perches, bluebirds use them. After we did the prescribed burn on the Sinlahegan, I think it was 2011, there were mountain bluebirds out there flying all over the place, apparently feeding. I don't know what they're feeding on, but...
Say something about dead trees later in the same
Uh-huh. Yeah. I think that's in your presentation, right? Yes?
So if you burn every year, like you said, the Methow did, that would pretty much eliminate the shrubs, but it might also eliminate the grass, right? And maybe primarily.
Yeah, I don't know about burning every year. In my reading and research, the Indians seemed to be burning certain areas intentionally. And they didn't necessarily burn every year. I mean, you have to read, you can't take all of this literally. And they would burn certain areas, and they had a pattern. And whatever, I'm sure they had war chiefs, and they had chiefs for this and chiefs for that, or individuals who were very knowledgeable about a particular discipline. And I'm sure that they had somebody that was very knowledgeable, or a number of people are very knowledgeable about that. One of the books I mentioned is called Tending the Wild by Cat Anderson. And it's incredible how the Indians, these were in California Indians who were burning, and they had to prepare the vegetation that they wanted for weaving baskets like 2 or 3 or 4 years in advance by burning or copicing, pruning these plants 3 or 4 years in advance, because they needed that material to make baskets at that point in time. They couldn't just run down to Home Depot or whatever and pick up what they needed. And in this photo, we've got the cheatgrass, bitterbrush skeletons, but we also have bunchgrass. And bunchgrass is a deep-rooted plant. I don't think that it would necessarily be lost if it burned frequently, but the shrubs are definitely in jeopardy in this cheatgrass situation. Terrace. And what caught my eye here is these areas that burned really where the heat residency was extended, and basically sterilize the ground or cook the ground so that there was no grass seed or any vegetation growing in there.
Can you estimate how long it would take for that area, that hot area, to recover?
I'll guess that cheatgrass is going to be moved in there by next year. Yeah, 2016. Yeah. Cheatgrass is reduced initially after a fire. It's significantly reduced, but after that it really takes off. Yes?
Is that if you had cheatgrass before?
Yeah, if you had cheatgrass before.
Because my property looks like that, but I didn't have cheatgrass.
Okay. So it's a good thing the Columbia River was there, otherwise I think it would have gone to Moses Lake. This is serviceberry. Why did I put in chokecherry? This is serviceberry. You can see these larger stems were killed in the prescribed burn, but the center stem survived, and you've got a lot of reproduction here at the base that the deer are just clobbering. Yeah.
So if the deer are clobbering that, would it be helpful to armor that, to give it a chance to get a little higher before you let the deer whack on it? I mean,
How much time do you have?
I'm thinking like 2 or 3 years with a cage or something to let the sprouts get up that high.
That's a nice thought. It's not practical. It's just I can't get people to build fences around their cottonwood trees that they don't want the bee cut down.
So if you did it long enough, it would work.
Oh yeah, it would work.
Okay.
But that's one thing about some of these real brushy trees like serviceberry or bitterbrush. And in one case, I recall an aspen tree that came down. There was enough interference with the deer browsing that it protected the regrowth of the plants coming up. So the deer weren't willing to stick their noses in or stick their heads in to browse it. It protected and did exactly what you're talking about.
How long is that? Is that after that prescribed burn?
This,
Next season, or?
yeah, that was the next. This was a fall burn, so this in the next June. can see the bunch grass growing up. Okay, this was an elderberry, a pretty big elderberry bush that was burned in May 27th. Well, this is when the photo was taken. I believe it was probably burned about May 20th or thereabouts. So you can see that there's some sprouts coming up right here. This is about 4 months and 1 week since the previous photo. So it really seemed to appreciate getting burned. No, that's a mustard. Speaking of fireweed, I believe that fireweed, there's some other species, aspen, that the roots will sit in the ground for years, if not hundreds of years, waiting for the conditions to give it the cue to take off. And I saw that on the Simmahegan, where we did a prescribed burn, and there had not been, the closest aspen were, I think, a half mile away, and there were aspen sprouts coming up, shoots. In fact, there was an aspen shoot coming up through a stump hole where the fire had burned down into the stump and completely consumed the stump. And that had to have been a tremendous amount of heat residency in that. But within 3 years, there was an aspen stem coming up.
Were those germinates or suckers?
I believe they're suckers. I had somebody come out on a tour on the Simmahegan, and they said they had a professor at the Colorado State University that said they'd give them $100 if they could bring in a seedling. Okay, this is some Shrub-Steppe on the Simmahegan. This is bitterbrush. This is bitterbrush. And you can see some of the plants, they're blooming, obviously. And you can see that there's, not all of them are dead. They survived. But if we were to come, and you can see how much greener the grass is on this side, and then on that side there's a fence there. And this is down by Winter Lakes. This is a bitterbrush plant that is sprouting at the base. But amazingly enough, there's some live material up there. So obviously there's live material all the way up to keep that going. And then there's sprouting, basal sprouting on this bitterbrush. This was taken on the Simmahegan, on the Chilliwack Wildlife Area. This entire area was burned in 1997, and the photo was taken in 2012, about 15 years later, and you can see the bitterbrush that was popped up. Seems to be doing fine. Yes?
That picture looks somewhat similar to some of the earlier pictures you had of the historical areas. Is that healthy?
Is this healthy?
Yeah.
I'd say this is healthier than what it probably looked like before that. I'm sure this had a lot more shrub, But
this is what the fire went through again, didn't it?
Yeah, the fire went through it again. Yeah.
And it
So
didn't-
I think
didn't help the lower Chilliwack.
No, it didn't help the lower Chilliwack. No, that got cooked pretty good. This is on the Methow Wildlife Area. And this is in October. And again, you've got bunch grass popping up, and there was a number of flowers that were kind of late bloomers, trying to keep it going. And again, I think that's a genetic adaptation that they have for this area being burned, and they're responding, trying to get some seed production. And little bitterbrush sprout popping up. Here's one right there. So the bitterbrush skeletons do provide some protection from deer browsing, although this is pretty well opened up. I believe that's chokecherry above.
Hey Dale?
Yes.
Okay, so it sprouts back. Sorry, this is back to where it was. The deer eat it back.
Yeah.
The deer eat it back. How many times can they do that before it dies?
I don't know.
Okay, thank you.
Okay. There's no substitutes for fire byproducts or fire effects. People talk about fuels reduction, and what they have in mind when they're doing fuels reduction is going out and thinning trees, putting them on the ground, slashing them up, piling them. Now that's not fuels reduction, that's fuels reconfiguration.
Yeah.
Fuels reduction is when you remove it from the site or you burn it. That is reducing the fuels. Okay? Don't let anybody tell you that just by going out and thinning and you know cutting down that ladder fuel is fuels reduction. It's not, it's reconfiguration. Okay, there's 4 fire byproducts: charcoal, ash, smoke, and heat. All 4 of these byproducts are essential in a fire-dependent ecosystem. Fire effects include reduced fuels, rejuvenated vegetation, thin forests, and more groundwater, to name a few. Fire byproduct, charcoal. It's the most stable form of carbon. It absorbs 5 to 7 times its weight in water. It increases the water holding capacity of the soil. It contributes to soil building. Mitigates effects of allelopathic chemicals released by noxious weeds. Are you familiar with the term allelopathic? It's a chemical that's given off by, toxic chemical that's given off by individual plants to reduce the ability of other plants to survive next to it. So it gives you a growing advantage, competition, better competition, more competition, competitive with usually native plants. And based on the situation, it stimulates and or suppresses germination of seeds of various plants. Fire byproduct, smoke. There's a chemical in wood smoke that it provides a cue to increase germination rate of certain seeds and seedlings. Basin wild rye and bitterbrush are 2 of those plants that take advantage of this smoke cue.
What is that a picture of?
These are actually photographs of some plants that they actually discovered this in Australia. So these are some plants that responded to that smoke cue, and these are Australian plants. Fire byproduct ash. Nutrients and minerals are released and fertilizing new growth after the fire. This is a prescribed burn area just as it's cooling down. This is in the spring. And then again, another example of the ash providing a burn flush vegetation. And the fire byproduct of heat, it is a cue or scarification of the seeds to get them to germinate. This is a particularly hot burn. This is a case where the more cooking of the soil is a good thing. Ceanothus depends on heat to get the seedlings to germinate, and you can see the profusion of young ceanothus plants right there. And in the Simlahican, there was a deer food study done in 1983, 84, winter of 83, 84. And it was October, November, December, January, February, and March. And out of, I believe it was 4 out of those months that the ceanothus was, at one point, it was 48% of the diet. And the other months, there were 2 months it was over 25%, and a third month it was like 15%. But during that whole time, ceanothus was in the top 50% of the diet. So if we keep fires, if we exclude fires, or do our best to exclude fires from the landscape, we're not doing deer any favors. This is based on that study. It's a one season study, a limited study. But based on that study, you're taking away, an important or a food item. There were no mature ceanothus plants in the site at all. These seeds, according to the literature, will sit in the soil for up to 400 years. This is fire effects, top killing and reinvigorating the growth. That's that elderberry. And vegetation mosaic. In a vegetation mosaic, again, this is down by the terrace. You can see this is totally blackened. And then other areas where the needles were scorched. And you've got a mosaic, creating a mosaic on the landscape. And that's very important for wildlife habitat, to have that diversity on the landscape. Despite what Smokey Bear said. Fuel reduction. Recently burned areas don't burn. These are areas where I burned some slash piles in the winter of 2004. And we conducted this prescribed burn in the fall of 2005, and the fire came through here, and it didn't burn the grasses that were there. Additionally, in the spring, we did some black lining. Going out, we put in a fire line, and then we burned next to that fire line to decrease the fuels between the fire line and where it was burned. And by doing that, you're increasing your buffer, your boundary. And that fall, when you're trying to burn, a number of the igniters were out there that were trying to get the grass going. They couldn't. It was burned. There was grass standing there, but there was no continuity. So they had to move out of the area that was black lined into the area where there was more fuel before the fire would take off. Fire effects, increased water availability. Now this should apply here in the Shrub-Steppe of Okanagan County, where precipitation is greater than 16 inches. This was a stream bed, and this dot, it corresponds to that dot, and this triangle corresponds to that triangle. And there was a prescribed burn. This is in California. It was conducted in, I believe, August, and this was about a month later. And the description said that the water flowing through this stream channel was about 3 or 4 inches deep. And there had been no precipitation. This is just an effect from reducing the amount of water pumps on the landscape. Water pumps meaning trees and shrubs that are using that water, pumping that water. Okay, for the future, More controlled fire is needed. But removing the option of controlled burning did not stop the burning, it just removed the control.
Did you make that up?
I'd like to claim I did. Fire exclusion versus fire suppression. Fire suppression, extinguishment of unwanted, illegal wildland fires, consequences, protection of natural resources, landowner improvements, and the public. Fire exclusion, the attempt to completely remove fire from the landscape, consequences, escalating, suppression costs, decreased probability of success, unnatural ecosystem changes, and increased risk of firefighters and the public. Stephen Pine, if you're inclined to do a lot of reading, Stephen Pine is an author that I would recommend if you want to learn more about fire. He is probably the world's top fire expert. And he wrote, terrestrial ecosystems store carbon, but withdrawals are periodically demanded. The fire tithe, so to speak. This tithe can be given voluntarily or it will be extracted by force. And I think we've seen where it was extracted by force. And here's proof positive of global warming. Wildfires are projected to worsen with climate change, and this has been repeated many, many times. I would imagine that Paul and Susan both mentioned that in their presentations. That we can't continue to sustain fire suppression or fire exclusion, I should say, policy. Future shrub-steppe management. The deer obviously like this. There's one right here, there's one right here, one right here, and there's one right there. So they were scattered through this. But if you get a fire coming through there, again, it's not going to create a mosaic. It's going to be a homogeneous, overly burned area. So we need to go into these areas, and I am of the opinion to burn patches and burn, create mosaics in these areas. So when a wildfire does occur, it's not going to be one continuous hot fire. And again, Stephen Pine. The missing fires are those that were once set by the now missing peoples, the Indians who were removed, and the newcomers who, on the public lands, failed to pick up the Indians' fallen torches. But returning fire to the land in hopes of restoring pristine pre-Columbian vistas is not one of them. We must reinstate fire because we cannot sustain the landscape we value without burning. We should reinstate fire because burning is what we do as human beings, as holders of the species' monopoly over flame, for whom fire neutrality is not an option. We have no choice, no more than did American Indians, Australian Aborigines, or European peasants. We must decide how to apply and withhold fire in the landscape because we still remain, all of us, all peoples across 100 millennia, the keepers of the planetary flame.